Children, you will be learning about cyclic quadrilateral. When a quadrilateral is drawn and a circle is drawn around the quadrilateral, that is when a circle is circumscribed around a quadrilateral, then we call this quadrilateral as a cyclic quadrilateral. Okay, I hope you understand that. We have already learned it. Okay, when a circle is drawn around any polygon, okay, we call it as circumscribed. Here the circle is circumscribed around a quadrilateral. Now this quadrilateral we call it as cyclic quadrilateral. The points at which it touches the circumference of the circle, we call it as concyclic points. Understood? Now in theorem number 8, theorem 8, what we are trying to prove here? We are going to prove here the opposites angles of a cyclic quadrilateral. The opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilateral are supplementary. This is the statement. The opposite angles of a cyclic quadrilaterals are supplementary. What do you mean by supplementary? It is equal to 180. Now we need to prove this, and you should remember this statement also. The opposite angles of a cyclic quadrilateral will be equal to 180 degree. Even during construction I taught you this. The opposite angles of a cyclic quadrilateral, any quadrilateral is supplementary. Okay. Now how we are going to prove that? Now what is given? Given now A, B, C, D is a cyclic quadrilateral. A, B, C, D is a cyclic quadrilateral. Okay. Now O is the center of the circle. Inscribed in circle O. So this quadrilateral is inscribed in circle O. Now what we need to prove? We need to prove that angle ABC, this angle ABC plus angle ADC is equal to 180 degree. Okay, and then angle BAD plus angle BCD is equal to 180 degree. Now this is what we need to prove. Now for that we have to do little of construction. What's that construction? Join OA and OB. We are going to join OA like this, and see, let me take the center here. Join OA and OC. I have to join OA and OC. Okay. Like this. Now you know this is the center of the circle. Now from the first theorem, what we have learned, the angle in the center is twice the angle on the circumference. What we have learned in the first theorem, angle in the center is double the angle on the circumference. Twice double means same. So now let's write the proof. statement, reason. Okay. Now statement is first one, arc ABC, subtend angle AOC, subtend angle AOC at the center. And then it also subtend center and angle ADC at the circumference. Okay, it's see, this arc is subtends angle at the center and angle on the circumference. Okay, ADC, and then okay. Now, when this happens, what happens? The angle here, we have to give the reason. The angle at the center is 2 times angle at the circumference. Okay, so 2 angle at the center AOC. Angle at the center is AOC is equal to 2 times angle ADC. Okay, now this will be statement 1. Okay, now we'll move on to the next angle. Now we finished with this. Okay, now we have to move on to another angle formed. What is that? Now the same arc here is formed an angle at the center here and the angle at the circumference. Okay, the same arc ABC is formed an angle at the center here and angle at the circumference. Always opposite, remember that. Okay. There again what happens? This AOC will be double ABC. But remember, see, this angle is, if it is like this angle here, when you see here, this angle is acute or obtuse, this angle will be reflex. Do you see this? This angle is acute or obtuse or straight, whatever it is. This angle below will become reflex. So this is a reflex angle. Okay. So here we'll continue. We'll say angle, reflex angle. We need to write reflex angle. Reflex angle AOC is equal to 2 times. So this will be 2 times ABC. Angle ABC. The reason is same. Angles at the center is 2 times angle at the circumference. Okay, now this is 2. We'll take 1 and 2. Add 1 plus angle 2. Okay, 1 and 2. So here angle AOC plus reflex angle AOC is equal to 2 ADC, 2 angle ADC plus 2 angle ABC. This plus this. Okay. Now here, see here, this angle, acute or obtuse plus reflex will become 360 degree. This angle plus the reflex, this whole thing here will become 360. So this angle here will become 360 degree. Okay. So this angle will become 360 degree. Now this will be equal to, I can take 2 common. Say take 2 common. So here angle ADC plus angle ABC. Now bring this 2 down. 360 degree by 2 is equal to angle ADC plus angle ABC. Okay, so this, if you reduce it, it will become 180, which is equal to angle ADC plus angle ABC. Okay, now similarly, angle DAB plus angle DCB will be equal to 180. Hence proved. So we have proved it. I hope you have understood. I'll just go through everything once. Here A, B, C, D is a quadrilateral rod. Now you are going to circumscribe this quadrilateral. Okay. So this quadrilateral is inscribed now because it is inside the circle. Now this quadrilateral we call it as cyclic quadrilateral. The points A, B, C, D is called concyclic points. Okay. Now theorem 8. The opposite angles of a quadrilateral are supplementary. Always remember that. Opposite angles of a quadrilateral are supplementary. Okay. So we need to prove that the opposite angles are supplementary. Given ABCD is a cyclic quadrilateral inscribed in circle O. So it's drawn inside the circle O. To prove that ABC plus ADC is equal to 180. BAD and BCD is equal to 180. Now we have to do one construction, join OA and OC. Now proof, that is statement and reason. Proof is arc ABC. Now this arc ABC subtends angle at the center and an angle at the circumference at D. Okay. When this happens, what happens? The angle at the center is twice the angle at the circumference. Okay. So, I have taken angle AOC is equal to 2 times ADC. Now, this angle arc ABC also subtend an angle here and here. Okay. Now, I told you this is the acute angle or obtuse angle. This is reflex. So this is acute or obtuse, this becomes reflex. So the reflex angle AOC will be equal to angle ABC, 2 times angle ABC. So adding 1 and 2, what happens? AOC, this is AOC plus reflex angle is equal to ADC, 2 ADC plus 2 ABC. Now this angle and reflex angle together will be 360 degree. Now I have taken 2 common here. So bring that 2 down here. 360 by 2 is 180. So angle ADC plus ABC is 180 degree. Similarly, DAB plus BCD is also BCD. I'll write it. How I have written it in the BCD. Okay, this is equal to 180. So thus we have proved this theorem.